This is Chapter 4, Number 59, out of the Survey Physics for Scientists and Engineer book. A skier leaves the ramp of a ski jump with a velocity of 10 meters per second, 15 degrees above the horizontal, shown in the figure below, which is right here, shown in the figure below, 15 degrees above the horizontal. The slope incline is at a negative 50 degrees, which is a negative 50 because it's negative 50 below the horizontal. And the air resistance is negligible. Find A, the distance from the ramp to where the jumper lands, and B, the velocity component just before the landing. So here we've worked out the directions where the x direction is, we use the kinematic for the x and the kinematic for y. Found that in the x direction that x initial is equal to x final, and in the y direction, doing the algebra, we find that y final equals y initial, v initial y, minus gt. Now, I've already drawn the picture as I shown you below, and it shows the green is where the jump, the D is from the ski slope all the way down to where the skier lands. Here is the coordinate system here. A skier travels horizontally with x2 is x final, so x2 minus x naught equals x initial xt, which is 9.66 meters per second. Vertically we have y2 minus y naught, which is v initial y t plus minus 1/2 gt squared, which is 2.59 meters per second, t minus 4.90 meters per second squared times t squared. This component was gotten from the initial velocity, which was given to us in the beginning of the equation, and the components were gotten by using the v initial x equals v initial cosine theta, which is equal to the 10 meters per second cosine 15 degrees, which is equal to 9.66 meters per second. And the y component was we got from v initial y sine of theta, which is 10 meters per second sine 15 degrees, which is 2.59 meters per second. Now here's, like I said, vertically, that's where I got these numbers from. Now we need to be careful. Here's where you need to analyze the components. The skier hits the slope when y2, which is y final, minus y initial over x2 minus x naught, which is tangent of negative 50 degrees, which is equal to negative 1.19. Note that negative 50 is used because the slope is negative 50 degrees below the horizontal, as you can see right here in the picture I've drawn. Here's where we solve the equation simultaneously using our vertical y equation we determined above, and the horizontal x equation we determined above also, setting them equal to the slope equation, which is here. It's 2.59 meters per second. These are the ones that these are the ones here, this one and this one. So 2.59 meters per second times t minus 4.90 meters per second squared times t squared equals the negative 1.19 meters per second. I'm sorry, it's divided by 9.66 meters per second t, which then equals that. Then we did the algebra, took the 9, multiplied by 9.66 meters per second, which gave us 2.59 meters per second, minus 4.90 meters per second t squared is equal to negative 11.50 meters per second t. Then we minus 2.59 from both sides, which gave us the negative 4.90 meters per second t squared, which is equal to the negative 14.1 meters per second times t. Now we move the 14.1 over, just to the algebra, so we can get to 0, so we can factor out the t, factor out 1t, and we end up with the t equals 0, which refers to the takeoff point, and t equals 14.1 meters per second divided by negative 4.90 meters per second, which gives us a time of 2.88 seconds, which this gives us how long the skier is in the air. Now, using that time to solve the x2 minus x naught equals v initial xt, which is equal to 9.66 meters per second times t, multiplying it, we get 27.8 meters. Now, from our drawing, our slope components are the x equals d cosine of 15 degrees, which here we'll see d is from the point the jumper jumps to the point where they land. And the y component is the negative d sine 50 degrees in the downward direction, because remember, we're going in the positive direction, so that's why we use the positive 50 degrees, and because we're going in the positive direction, and we use negative because we're going in the negative y direction. Now we're only asked for distance, the x distance, so d cosine 50 degrees is equal to 27.8 meters, which means that d is equal to 27.8 meters divided by cosine of 50 degrees. So that gives us a distance of 43.2 meters. So the distance where the jumper lands from the ramp is 43.2 meters. Now for part B, the final horizontal velocity component is the x final equals the x initial, which is 9.66 meters per second, which we've got right here in the beginning. And the vertical component is the v final y equals v initial y minus gt, which is equal to 2.59 meters per second minus 9.8 meters per second squared times 2.88 seconds, which is equal to negative 25.5 meters per second. So the components for the velocity are 9.66 in the I-hat direction minus 25.5 in the J-hat direction meters per second. And that is the end.